Good morning. In our previous class, we have seen some activity which relates that the sound is produced by a vibrating body with the help of rubber. We have seen with the help of plate that sound is produced then when they are in vibration. Now today we will see the propagation of sound. Means that how sound move from one place to another. Okay, so propagation of sound means the movement of sound from one place to another, and this topic is very much important. As till now we have discussed that the sound is produced due to the vibration in the object. Means the vibrating object produces sound. And so one question comes in the mind that actually what vibrate? When I am talking, when I am speaking anything to you, how the sound is reaching to you? In the classroom, you see that in the classroom or anywhere when you talk, then your friend listen. So how sound travel? So the important thing is, for the traveling of sound, medium is required. For the movement of sound, medium is required. And what is medium? Solid, liquid or gas. Means sound can travel through solid also, liquid also or gas also. Means wherever there is medium, then only the sound is sound is produced. Why? A question arises that if there is no medium, like in vacuum, so what will happen in the case of vacuum? Will we able to listen the sound in vacuum? The answer is no, not at all. We cannot listen the sound in vacuum. Yes, as usually what we do when we speak to one another, suppose I am speaking, other person is listening to me. But in vacuum, if one person will speak, the other person will not able to hear. Why? Now the concept will be clear to all of you. When an object vibrates, then the particles, then the molecules around the medium also vibrate. Around the medium also vibrate. As you know that solid, liquid and gas, in all the three cases, you know one thing, that in the case of solid, the molecules are very close to each other, as you have studied in your lower class also. In the case of liquid, the molecules, there is intermolecular spacing, means the molecules are not very much close to each other. But in the case of gas, the molecules are far from each other. Means in a single line, if I have to define solid, liquid and gas, what I can say, the intermolecular space between gas is very high, in the liquid it is low, and in the solid it is very less, that we can neglect the intermolecular spacing. So when any object is vibrating, so what happened, the particle which is in contact with the vibrating object. The particle which is in contact with the vibrating object is first displaced from its equilibrium position. Means it displaced from its equilibrium position, and due to which what happened, the adjacent particle, a force is also exerted by this particle on the adjacent particle, and this adjacent particle also come in vibration. And like this process take place, and this process repeats in the medium till the sound reaches the ear. So it means what? The vibrating body, the disturbance which is produced by the vibrating body travels through the medium, but the particle do not move forward by themselves. The particle do not move forward by themselves. Means molecule, there is not the movement of molecules. Only what travel? The disturbance travel. What travel? The disturbance travel. So in the case of sound, molecules are required. Molecules are present where? In the medium. So the molecules of the medium vibrate. The molecules of the medium, what it do? It vibrate, and due to the vibration of the molecules of the medium, the adjacent molecules also come in vibration, and this process goes on till our sound reaches the ear. So sound is considered as a wave, and since these waves are produced due to the vibration of particles of the medium, since the particles of the medium are vibrating, and due to this the sound is produced, so these waves are said to be mechanical waves. See, there are two types of wave: mechanical wave and non-mechanical wave. Mechanical wave are those waves which require medium, and non-mechanical wave are also known as electromagnetic wave, which does not require medium. As you have studied that light does not require any medium, but sound require medium, because sound is produced due to the vibration, and the vibration, when the object vibrates, what happens? The particles of the medium also start vibration, and due to this the adjacent particles also come in vibration, and the first particle which was in vibration come to its mean position. Means it's vibrate along its mean position. Okay, it do to and fro motion, and due to which the adjacent molecules also come in vibration, and this process continue till the sound reaches our ear. And in this case, the vibrating body, the particles simply they vibrate on their mean position. They does not go from one place to another. They vibrates, and due to the vibration, the disturbance which is caused, this disturbance move from one medium to from one place to another. And a wave is what is disturbance? It is a wave which move through the medium, and since the sound is considered as a wave, and sound wave are produced due to the vibration of particles of the medium, and since it requires a material medium, so that's why sound waves are called mechanical wave. Sound wave are called mechanical wave. Now a thing arises in the mind that sound will travel faster in solid, liquid or gas. If the intermolecular spacing will be less, then the speed of sound will be more. That is, in the case of solid, the speed of sound will be more. In the case of liquid, it will be less than the solid, and in the case of gas, the speed will be less. This I will discuss in the next class. Thank you.